Hi, I'm Paul Craven, and I teach computer science at Simpson College in Indianola, Iowa. This is the print function chapter. Prior to this chapter, we got our computer ready to start coding in setting up your system. We did that by installing the Python programming language and an integrated development environment, IDE, called PyCharm. You can think of Python as the engine and PyCharm as the interface to the engine. In version control systems, we began learning Git. Version control systems allow us to share code, work on coding groups, and track changes to the code. We'll use that tool to track and share your code for every lab you write in this book. In this chapter, we'll write our first programs using the most fundamental of all tools in the programmer's toolbox, the print function. This function does exactly what you'd expect. It prints to the screen. While a lot of computer programs are graphics-based, text-only programs are still quite common with people that manage computers or who do data analytics. Even for the graphics-based games we develop in this book, the print function will be a vital aid in understanding and debugging our games. We aren't limited to printing on the screen. Later on, in example Saving High Score, we'll show how to print to a file so we can save the data. Programs can even print over a network connection, which is the start of what's needed to learn how to do web programming. Printing Hello World. We are going to use a function to output text to the screen. If you've already taken a geometry class, you've used the sine and cosine functions. In this chapter, we're going to learn how to use the print function. In programming, we use functions a lot. Functions are a basic building block in any computer program. Just like in math, when we use functions in programming, we start with a function name such as sine, cosine, and print. Immediately after the function name is a pair of parentheses. We put any function parameter inside the parentheses. In the example below, we have a function, parentheses, and a parameter. With the sine function, we put in the angle as a parameter. With the print function, we put in text we want to print as a parameter. Text must be enclosed in quotes. We'll explain why later in the variables and expressions chapter. Entering our program. Now that we've seen what the print function looks like, let's use it to enter our first program. The Hello World program is a simple program that just prints, well, Hello World to the screen. It is often the first program that any programmer creates in a brand new computer language. First, open PyCharm. From our work in setting up your system and version control systems, we already should have PyCharm and our project ready to go. You should be able to run PyCharm and see a window like this. First, click the triangle next to your project name, then find Scratchwork, and then finally print statements.py. Note, the most frequent mistake here is to have PyCharm open to the wrong folder. Make sure that all your lab folders appear inside the Learn Arcade folder. If they don't, select the File Open menu and reselect your project folder as shown in Open Project in PyCharm. Once selected, you should not have to do a file open again for the rest of the book. Once you've selected print statements, go ahead and type in your first program. Running our program. After you've typed in your program, right-click on either print_statements.py or anywhere in the code window and select Run print_statements.py. You should see the output of your program appear in the window at the bottom of the computer. Errors and warnings. Programs don't always work on the first try. In fact, they rarely do. As programmers, we run programs over and over again until we find the right code. If a computer runs into an error that it doesn't know how to handle, it will generate an error and stop. Don't panic, it's no big deal, we'll fix it. In addition to errors where the program doesn't run at all, Python can show us warnings. Warnings occur when the code runs, but something's not perfect. First, let's create an error. Change the print function to use a capital P, print. Run the program. You should get something like the following. While it might look confusing, what Python is telling you is that on line 1 of your print_statements.py program, it encountered a function called print with a capital P. But that function has not yet been defined. Python is case sensitive, which means print with a lowercase p and print with an uppercase P are as different as apples and oranges to the computer. The lowercase print function is built into the language, and Python knows exactly what to do with it. The uppercase print function is not built into the language, and Python complains with a name error that it doesn't know what the function is. Let's try a different error. Go back to using print with a lowercase p, but remove the parentheses. When you run the program, now you get this. This is a different type of error, a syntax error. The term syntax actually originates with human languages, not computer languages. Both human and computer languages have an expected structure to them. A statement in English takes the form of a noun followed by a verb. Rob runs. That's a valid statement, while runs Rob is not a valid statement. The computer expects a function name to be followed by parentheses. If your program doesn't follow that pattern, it can generate a syntax error. The type of error and the line number are both important clues on how to solve the mystery of what caused that bug. Warnings. It can be possible to write code that runs but isn't quite perfect. For example, let's take our Hello World program and add some extra spaces. Go ahead and run the program. Should run without any errors. The Python standard is to have no spaces between the function name and the opening parentheses. However, this code is close enough that the computer can run it fine with no errors. In English, if we go to the store and say, "I'd like to buy 1 apples, please," our sentence is not grammatically correct, but it is close enough that anyone could figure out the intent. Why fix these warnings? When finding errors in code, programmers spend a lot of time looking for things that are out of place. If all the code is formatted in the same way, it is easier to scan looking for problems. Any inconsistency forces the programmer's brain to stop and figure out if that is important. Removing these inconsistencies makes debugging easier. You can find warnings in your code using PyCharm by looking at the right margin. Any yellow line is a warning. You can hover over it with your mouse to find out the details. Another warning you might encounter in your first program is the Python style guide states that all programs are supposed to have exactly 1 blank line at the end of the file. If you get into the habit of fixing these warnings, you'll learn to write code that will be easier to maintain. No, warnings aren't just about style. You might also get a warning about an error that really could occur during the program. For example, if instead of passing a number to the sign function, you might have written code that passes in text. That's not going to work. Weak warnings are warnings that mostly are just about style and aren't likely to end up being errors. Strong warnings point to code that the computer feels will probably end up being an error later on. Multiple print lines. We aren't limited to one print statement. We can print multiple lines of text with multiple lines of code. Let's change our Hello World program to the cliché opener for melodramatic fiction. It was a dark and stormy night. Suddenly a shot rang out. Your output should look like this. If quotes are used to tell a computer the start and end of the string you wish to print, how does a program print out a set of double quotes? Now, note, a double quote is not 2 quote marks. This is a double quote. This is a single quote. This is 2 double quote marks. Now, this code doesn't work. If we try to run it, we get a syntax error. The computer looks at the quote in the middle of the string and thinks that it's the end of the text, and then has no idea what to do with the text after the quote. It doesn't expect text after closing quote, so we end up with an error. It is necessary to tell the computer that we want to treat that middle double quote as text, not as a quote ending the string. To do this, we need to use an escape code. An escape code is a sequence of characters that can be used to print an otherwise unprintable characters. All escape codes in Python start with a backslash. Now note, backslash leans backwards and a forward slash leans forwards. The escape code for a double quote is backslash double quote. If we run this code, it does not print the backslash, nor does it error. We get almost every language has escape codes, and many of them, C, C#, Java, also use backslashes just like Python. Here's another example. This will print. Because the backslash is used as part of an escape code, the backslash itself must be escaped if you want to use one. For example, this code doesn't work correctly at all. Why? Because backslash n is an escape code. To print out the backslash, it is necessary to escape it like the following. There are a few other important escape codes to know. Here's a table of the important escape codes. Backslash single quote, backslash double quote. Backslash T is a tab. Backslash R is a carriage return. Backslash N is a line feed. But what the heck is a carriage return and a line feed? Well, go ahead and try this example. The output from the command is the backslash N is a line feed. It moves the cursor to where the computer will print text down one line. It knows to display the text on different lines only because of the placement of backslash N characters. Before the internet became commonplace, computers actually didn't even agree on what characters to use for line endings. Backslash R, backslash N was used for Microsoft Windows. Backslash N was used on Unix-based systems and newer Macs. Backslash R was used on older Mac-based systems. Having different standards was annoying when computers got connected together on the network. The post-internet standard is to just use backslash N for line endings. If you use an escape code, don't put spaces around it. Don't unless you want spaces to be there. For example, this code might look better, but it will print extra spaces before the words. Triple quotes. If you have a block of text and you don't want to spend a lot of time putting quotes around each line, you can use triple quotes. This code will run and print out like the following. It is tempting to put in an extra blank lines or indents. Don't do this unless you want them in the final output. For example, this code may look better, but the output will include all those extra spaces. Review. In this chapter, we learned one of the most basic building blocks of a computer program is the function. The first function we're learning is a print function used to output information to the screen. We learned how to use that function by entering and running our first program. As programs don't always work the first try, we learned about name errors and syntax errors. We learned that code has a style guide called PEP8 that defines how the code should be formatted. Printing multiple lines is possible using three techniques: multiple print statements, escape codes, and triple quotes. We also learned about escape codes that can be used to print quotes and tab characters.